starten. Bildschirmfreigabe. Bildschirm Nummer 3. Zack. Gut. So, with regard to reading and writing files and using QIO device. We did not close this. Let's make a small new project and call it QTIO. That sounds reasonable. Create new project. Let's go with Qt console application. QTIO. Okay, so first we of course need to include some Q file. And if we let's create some file which will be reading file, in file. One thing to keep in mind about Qt and its handling of files is that it accepts paths written the same way as you would do in on Unix, so you can use forward and backward slashes. I'm just looking for some file of a non-negligible size which we can take. Let's take this one. 40 megabytes, that's good enough. So this is the Windows way where you need to escape the characters, but if you write it the Linux way, Qt will be completely fine with that as well and also accept this path. Also, if you get, for example, the file name from the function again, name, rename, file name, it will always return it in this format, even if you feed it the Windows style path. QString test path. It will give us the it will give us the Unix style path, so we can quickly check that. That's a bit of a small detour, but since we are looking into QTIO and how it works in more detail, then it's good to start at the beginnings, I would say. And zack. And we see the path is Linux style. So if you are retrieving the path and then want to do something with it that's like give it to some Windows application, sorry, not Windows, well, Windows application as well, but mostly important to some Windows API, then you would need to change the forward slashes into backslashes again, which is quite easy. You can just do it by something like this, if you would want to, if you would need to. But we don't care. That was just a short tangent. Okay, so we have our file. Now we open it for reading. Open Q file. Read only. We can check if we actually opened it successfully. Then let's create a second file, which we'll be writing to, out file. Punkt, out file. If open Q file. You can also type QIO the hitze. You get access to the same enums, and the write only option ensures that if the file was not empty when you opened it, then it will be truncated to 0 when you open it, because you only want to write to it And it's reasonable to assume that you just want to provide new content and don't care for the old one. If you would want to actually modify the file, you would have Qt read write available. Actually, there is an explicit truncate, so I guess if you really wanted to truncate, you may need to add this. So let's do that. Actually, usually assume that write only would truncate it automatically, but since there is explicitly a truncate, then let's truncate it as well. So we we make sure the file is empty. And now we can start reading it. So let's create some buffer array. You can provide the size of how much we want it. Let's make it a couple of pages, 16 pages. The thing will want to have some initialization value, so let's feed it this. Then we can read from one file, so we make a loop for the beginning, infinite loop. Then we have our in file, read, and then there are two options how this. So the read function, there are a few implementations of it. There is one which just takes a length and returns you a new qbyte array, which means it will allocate new memory, and all in all this will be less efficient than if you would reuse an existing array. And the second implementation just takes a pointer, so this is what we want, data and size. We have to tell our read function how much it can read, and the read function returns an integer denoting how many bytes have been read. So q in 64 read, and if it fails, then it returns 0. So we check if this is not 0. If this is bigger than 0, then we can now write to our out file, and there you can just pass either. Actually, have three options. You can pass a byte array if you have it. You can pass just a character, a C string, basically a null terminated one. So here it will just write until it finds a null character, and you can provide a buffer with pointer and size to be written. Just that, of course, we cannot use size. We need to use our read value, and ideally we would check whether it wrote as much it had to read. So in 64, and if read ungleich written, you can include qdebug. It gives us a nice output. Qdebug. Write arrow. Okay. So now we just need a break condition, which we can get from our inf. Missing a, and we need a break here as well. But we need a break for our loop, so let's go with the in file. Was it at end? So at end will be true when there is when there are no more data in the file. So let's run this quickly and see if it works correctly. We forgot to close the file, but if we terminate the application, it will close the file anyways. But we should add an explicit close to be on the safe side. Suck. And it created. Okay, one refresh. Did not work. Okay, it did not work, so let's. I guess it didn't flash the buffer, so let's add out file right, yeah. So one needs to be here, in close, and here, well, there, out file right, both file, that should be fine. Let's try again, this time with properly closing the file. And if this doesn't work, we will need it must work, it cannot not work. We did not get any error messages, so it read it properly. Huh? Why is that 0? Could be that that this one is not working correctly. I guess that might be one of the problems, but it should be working. At end should normally. Okay, our at end is not working. Why is that? So we take the input file, open it for reading. That should work. Okay, we can also take we can take size. So as long as size is larger than in file position. So position is the current position where it reads. Each time read is or write is invoked, the position is incremented when the file is opened, then position of course starts at the beginning of the file. I'm not sure why at end didn't work. Maybe that end is only available if you have a streaming device. Qt q file at end. Yes, now it works. We can test if it. Okay, we don't have a comparison tool installed. We can hope that it's right, or what we also could do is we can, since it's an exe file, it probably has a signature. So we can just check whether the signature is still valid. Digitale Signatur. Details. The signature is valid. So if it would not be, so if the file would have changed, then the signature would no longer be valid. At end. Oh, stupid mistake. We of course need to negate at end. Okay, let's try it again. So we can delete this file. Suck. Yep, it's working. So I just was not careful enough when writing the code. Okay, so this is how you can use this, and if you want to change the position in the file, do we have a good idea of an example of doing that? We could make something that cuts the file up in chunks and then put it back together. Int e is null e++. So we take our out file in. We read a chunk and we close, and if we have an error here else, then we will also throw an error. Open. And if we are already at throwing errors, we can also make a another open arrow. Open arrow for open arrow for read. And we need to change this to we should make it more elegant. QString path. Or let's stick with our test path, but we'll still use it. We just call it str path. We'll leave it the way it is, and for here we will string %1 punkt %2 punkt part %1 arg e field width, let's say it's 3 characters wide, and let's fill it with zeros. Why is that complaining? It doesn't probably know what to do. Yeah, damn it. Let's quickly disable this autocomplete because this is really annoying. Where was that? Where did my mouse go? Huh? Oh, here. This one. Yes, finally. Okay, so we make a new file name, which is just the existing file name plus a number which always has 3 places or more if we need more, and .path, and then it writes these individual parts, and the last one will be of course smaller. So let's run this. Okay. Huh? It didn't work. Should have worked. I threw an error. Error open for write y. Was something wrong with the file name? String path is the path from there. Out file, that should be working. Let's see. Also, we probably should make something substantially bigger since it's a few megabyte file. Let's cut it up in 16 megabyte large chunks. I already had the 16. Shit. Minor typo. We need a breakpoint. It should be I mean, it's not what it should be. I'm not sure why. I say it. I wanted just 3 characters long, then it should take 3, and here it should not. Oh, no. 0 is also correct. Let's just ignore that for now. I think we somehow I think we somehow got a 0 character into the file name there. That was not correct here. Okay, now it's fine. But why was that wrong? Let's see. Okay, so what we can specify a string, we can specify another string, character, double, unsigned short, unsigned int. Field width 3. Base, I forgot to specify the base. 10, and then it probably would also properly accept this one. No, it doesn't, so let's stick with defining that. Okay. Yep, now the file name is right. Although we probably should start at 1 and not at 0, since this is supposed to be human readable. And it split it up as it should, so let's quickly delete it. Run it again to recreate the parts 0 through 3 with the right index. Okay. Now we can make a function that would do the opposite and then just merge the file back together. So let's turn this off. Okay, so we will need some input file name. Okay, let's okay. There is no condition. E++. Okay, so we will need this. We want to start at 1. Then we open for reading this time again. Suck. Open read. New path. String path, open read. Okay, then we will want to open our output file for writing, but not with the truncate option. So this will only open the path. Well, not quite. We need to add something to it. Plus .temp, so that we don't overwrite our original file. We said we don't want to truncate it, and okay. This goes here. This goes there. Okay, and ideally we could also just enumerate the directory, but for now we will just go with this method. So we check if we can open it, and if we don't, then we will just break, assuming there are no more files. Okay, so we have the file open, and we need to close here, there. Out file close. In file close. Yeah, it's not the most elegant approach, since we might want to cut the file up in parts even bigger than what can fit into our memory. So ideally there we would implement it such that we still do the reading in smaller chunks and not in chunks of the size of the file. So we have our in file, read the block, to the out file we write the block. If we have a read error, is an error. If we have a open error, we just break without any comment, because that means that there is no more file, since we are not checking whether it exists, although we could do that, but not now. Yeah, and I mean this is a bit easy, so we would want to maybe demonstrate this seek. So if we want to set the offset at which we want to write, use this seek function, and there we can specify the offset we want to go, and the offset in this case would be I minus 1 times size of buffer. And this will then each time go to the position where we need to be. Although, of course, this is not really super elegant, since it assumes that all the files have the same size. So actually, not seeking is safer. This really only works if we have files of the same size. And normally, when we are putting file one to the next, we would of course want to seamlessly stitch them together. There is no really point to do it, but just for purpose of demonstration, I'll leave that in here. Looks like an endless loop. Why? So we try to open the file for read only. Oh shit. The in file must be this, and the out file. The out file was fine. We can delete that. Now it should be fine. Yep. And our file has the right size. So this much about a quick crash course into Qt file operations. Are there any questions? Yes. Anything else? Mm-hmm. That would be the most multi-threaded way of doing it. It really depends on how you implement it in the end, because with Qt you can do it also without threads. With Qt you could use this signal and slots mechanism and these notifications to have more or less the management of the whole operation running in one thread, but then you would need some background threads which would do the transfer operations. And if you look into the implementation of RQ UMTCP, there are already a couple background threads which are started each time we do something. So we have the one thread which is started when we listen, and when we create any outgoing connection, we also start a new thread for that. So here you could have some additional worker threads which would talk to our existing mechanism and then send out Qt events, so that most of your logic would be in the main thread and would not need to be multi-threaded. Each connection makes, so the outgoing connections makes a thread, but the incoming connection receives all the incoming connections on one thread. So we have one thread per socket, basically, and if you create an outgoing connection, you create a new socket locally, while all the incoming connections come in on the same one local socket. It should not. So if you create different threads and each thread creates an own socket, then the mechanism internally will be able to keep them apart based on the port number. So we cannot create a port with this. So we cannot create a socket with a port which is already in use. So this way, each time we create an outgoing connection and a socket for it, it will allocate another port. And then the receiving end, even if it gets communication from two threads from the same other remote client, based on the port number, it will be able to turn them apart. This will not work anyway. No, on the receiving end, you have one port, and this is fine. On the sending side, you have, when you send data on the sending side, it automatically creates you a new port for the sending operation. We can maybe demonstrate that with one of our examples quickly. Let's start this. And we will need something to view the sockets. Where did I put that? It's not running yet. There it is. So here you see it opened automatically 2 sockets, and each time we would create a new outgoing connection, it would open another socket with another number and another number. So when you receive the data, even from the same client with the same IP address, you will see that they are coming from a different port number. It should. Just wondering why it's using up so much CPU. Is it doing? It should start doing things once it starts. We need to set this to 1. Threads. Let's quickly check why one of the threads is running all the time. Normally it should. We are updating apparently something quite too often. Timer event. Let's quickly improve on that. So how often we call this timer? 60 times per second might be too often. But well, that should be okay. So if this test thing runs too slow for you, you can just enter a larger number here in total. So here we really try to create one new entry per per frame, but that's probably far too often. Like 10 times per second would be already enough. Is run test working? No, it's not. Okay, so coming back to our example, there was an error in the code that Mr. Schwarzer found. Where was that? Here. When we are trying to read the data from our socket, here we forget to advance the buffer position for subsequent invocation of the for loop. Here, and of course then to move the receive position and finally reduce the buffer size remaining to be read. So these were mistakes. I will re-upload the example again today. And since we had apparently one bug, it probably would be good to test whether our hopefully reliable transmission protocol is actually reliable. So we can do it in our existing sample here. We just need to, where does it start? So we have here our run test, and when we let's quickly check. And what we can simply do is to write some known data, and then when reading, checking whether we receive what we have written. So window limit drop Mode 100, or we can set this to 0. It's working. Do we have a socket allocated? Yeah, we have a socket. Is it not connecting? Something's not working as it should, apparently. So we have only here our updates, but for some reason it's not sending data. It creates two sockets. So using TCP. We could also check the debug log that we get, if it prints any. Okay, so it tries to connect. That should end up with a success, but it does not. Okay, so we are waiting here for the connection to connect, and it does not connect. It never notifies the connection. That is not great. Connect event. Let's see. Oh, sorry, stupid mistake. I turned off the network card. That cannot work without the network card. And I think somewhere else I also had a change in the code. So probably it's actually working fine, but I remember one more thing which I did somewhere, that we wanted to use this package relay. So probably, no, but this is set to localhost. So actually, if it's set to localhost, then it should be working. No, I know why. We had locally some package relays established. This is why. Relay. We need this thing to run. Yeah. Open. Is that working? When I pressed open, it should be open. Let's see. ODP relay. Okay, it connected. Let me quickly check whether the packet relay is still up and running, or if that needs to be restarted as well. Okay, the packet relay is still up and running. So now, if we start it, it might work. If it doesn't, we will need to quickly check at which place in the whole chain of relaying packages over and over again it breaks. This package, yeah, now it's working. Good. So if we here run the test, yeah, okay, everything's fine. Although we have quite a few unexpected egg packages, that does not seem right. No, I know. I remember we had the problem that it sometimes duplicated packages somewhere along the line of all this relaying through different NAT ports. So for now, I guess we will just not use the relay for that to debug it, since we don't want to introduce another source of errors. We just want to check whether the mechanism itself works fine. So we just need to go to our connect function again and specify our own port, such that we don't. Where was that connect? Not here. client bind disconnected. We have somewhere a listen as well defined. It was in test server. Listen with listen. Here, so this is our listening port. Okay, so we just comment this out, enable that, and here bind, we can bind it wherever we want, but we want to connect to our port. We don't really need bind in this case. So the bind we only need if we are using this packet relay for it to know where to relay the data back to. But if we now just use localhost, that should be fine like that. Okay, so this works, and when we run the test, it seems to be working just fine, at least with regard to not getting garbage data. So now we need to add the aforementioned a verification of payload. So test client, what do we send? Which end is sending? So here we have a send, but only once, and then we are sending it over and over and over again. Okay, so let's do it maybe somehow more elegant. I'll copy this code block. Disable the original. Let's put everything into the code block so that we don't have unneeded things anywhere. Okay, so we will not have like a dedicated send buffer, we will have a receive buffer. Well, we will need a buffer at some point, but currently we don't assign any content to it. And we leave send len undefined, so we can sleep, that's fine. We don't send here anything. Right, you on the server side. What does it do? It accepts a connection, it creates a new thread which receives the data, and it was supposed to send them back. So let's say that we do that. We have our receive buffer, it will receive data and send them back to the server just as it received them, that is fine. And now here what we will do is we will generate we'll fill our buffer first with something long and reasonably recognizable. We will send it, and when we receive it back, we will verify whether it's the same thing which we have sent. So, and we will do that in a loop. We might need some more loops, but that's for later. So, for is kleiner send buffer array size plus plus. Okay, is it not defined? Num. It will also not be defined in this version. Okay, washed. Let's quickly define our own array size operation. X. Oops. I mean, this is completely unnecessary what I'm doing right now, because we are normally because we have a character buffer, so the size, the array size, i.e. the count of elements in the array is equivalent to the size of. But always when you have an array, it is recommended, if you want really to go for every entry in the array, to use one of these array size operator functions, or in this case a preprocessor definition. And there is one defined in one of the later revisions of C, but we didn't have enabled that. And Windows also includes some of the definitions that do the same thing as here. The idea is we take the size of the whole array, and then we divide it through the size of the first element in the array. And since all the elements have the same size, the result is the count of elements in the array. Okay, so we do this, and now we can go to our send buffer. From I is equals rand modulo. Actually, we don't need modulo, it will truncate it anyways. So let's be lazy about that. So we fill our buffer always with random garbage. Then we want to send the entire buffer, so we need to set the length. Then send. Actually, we could use it like send length is equals 0, send len plus plus at send len. Yes, that should work. Okay, so now int send is 0. We need a for loop because we want to send the whole buffer. Here send total. Let's call it send total, and let's go with. Actually, we could put this as a member into our for loop. Okay, send total must be less than send length. We don't need any plus plus operation because that we'll have later. Zack. Is equals. Okay, so if this is if this is greater null, then that was successful. We send something. So send total. Okay, this is wrong here. This we need fixing. Plus equals send. Also, we want our send buffer to be much bigger. Let's go with I don't know, a megabyte of data or 10 megabyte. Let's go with 1 times a megabyte, and then we can dial this up as we go along. Let's write it like this so that we see it. Okay, so we fill a megabyte of garbage. Then here we need to advance the buffer by as much as we already have sent. This is of type character, so we can use the plus. And to send, we probably should not use send length, but something more reasonable. Int to send is equals. Int to send is equals total send minus send length. So we have the remaining size to be sent. And since we know that we will run out of buffer at some point anyways, we can, if to send is more than, I don't know, a couple kilobyte, 16, to send is larger than 16 kilobyte, then we truncate it to be just 16 kilobytes. And if it's less than that, then it means it's the last block we are trying to send. Okay, so we have here our to send, we have our send total, we have our buffer, we have how much we have sent, we then increment our send total by send, and we should sleep. Since the buffer was full, we should give the mechanism time to send everything out, and then we continue with the next loop. We don't have like an error handling yet, which would be good. Wait, how does this is implement? I think we return 0 if the buffer is full and -1 on an actual error. Yeah. So actually we can here send. So if this is greater 0, then it was okay. Else, if this is less than 0, then it's an error. Then we break, and we can print an error to the screen. Oops. Send error. Okay. Yeah, and if it's null, wait. Sorry, that's not right. If this is successful, then we just only increment and continue. If we have an error, we have an error, and if we have, so this else case falls in the only left possible configuration, and then we want to sleep to give it time to send the data. And once we have sent everything, then we will, well, the other thing will receive it, and then it will start sending it back, and then it might end up on our end. This is not yet perfect, because since we are sending it back instantly, this means that here in the loop we will basically block our own receiving buffer, so we need to take care of that as well. So let's make our receiving buffer also large enough. And then while we are doing this, we will need already to query the receiving buffer, the receiving function. And then once we are done, keep querying it until we have received as much as we wanted to. That would be, of course, elegant to have here 2 different threads, one sending and one receiving. That would make things too complicated. Yeah, so let's just do it in here. Int receive total is 0, and each time we do our loop, we try to receive something. So client let's found our receive buffer plus wherever we already are with our receiving. Oops. Comma well, max proof, we don't really have a max proof, we really can go with a maximum. So to let's found to receive, and to receive will of course be let's found. We have not filled that. So here we need to fill it with the send length, since we know we expect the same amount to get back as what we were sending. Let's faulen, send total, receive total. Okay. And if this is greater 0, then receive total plus is gleich received. And then once we're done with that, we either make a second loop or we try to actually be smart about that. So we make one if here, make another if there. Should be the nice file. Okay, and then we just will need to have something to break the loop once both conditions expire. So this or that. Yeah, this is not perfect but elegant enough. And then once we are done with receiving everything, why is it in a loop? Because it repeats the test. Okay, this is fine. Let's write here start test, start random payload test. Start random payload test, so we fill our send array, we send it, we receive it, and once we are done with both, we need to check the results. So memory compare, let's v buffer, comma send buffer, comma so send length, send length, since those are the same at the end. Yep, and this must be 0. So if this is 0, then we can print a success message. Oops. Else, if it's not the same, then test failed. And then let's make a sleep of 3 seconds and repeat the whole thing again. Okay, let's run and see if it does what we expect it to do. Okay, we crashed something that is not good. Why? Why did we crash at the very beginning? That is... Oh. That was a stupid mistake. We cannot allocate so much space on the stack. We need to allocate this on the heap. Or we could be... or we could allocate it statically. But then, of course, every instance of the function would share the same buffer, so this would not really be that elegant. So let's go with allocating that dynamically. Or let's go with char, with new char. And once we are done with everything here, oops. That's foul. Okay. Let's run it. So this is actually a good that this mistake happened, because it's something you should remember, that you cannot allocate arbitrary large amounts of data on the stack within a function. So if you want to handle megabytes of data, why does it print equal signs? Wait, but okay. We will need to change our server to not print what it receives. And also I'm not sure whether our random numbers are really random. They somehow don't look very random. And let's put a breakpoint here and inspect our random buffer. The whole idea of filling it with something random is that if we have an error which would repeat some pattern, then we could wrongfully think that it's right, while it would not be. Oh shit! Array size, of course, does not work if we use this, because it's just a pointer. Then we of course need to introduce a new variable, int let's call it test length. And our test length then will be passed here and used instead of the size of instead of the array size operation here. We only used this once anyways. Okay, so what happened was that we only filled the very first few bytes with random garbage, and the rest was just the value that the heap manager assigns to unallocated memory when in debug mode. So it's doing something, and at some point it should tell us what the result was. Unless it's broken, but I don't think so. Huh? What happened here? I just moved the mouse. Okay, let's make a breakpoint here and see what it's doing. Okay, it's too busy sending data. We should add some sort of progress indication. That would be nice. And it should not be broken, right? No, it's just... Is that a megabyte? That sound looks like a megabyte. Yeah, it's probably just really fast. Although I thought I saw finished message within the garbage that we got from the other thing, so let's see. But it's still, the send total is still getting larger, so it seems to be working. Of course, if this is the performance we have, then we need some improvement on that, because this would then mean that our performance is rather bad. BD, yeah, that will take forever. Let's go with a smaller data block, but then probably something is still broken with our mechanism. Let's go with I don't know, 16 kilobytes of data. Probably we should turn off that is successful. Okay, so with a smaller data set it worked fine. Yes. Just to speed up things, I will was it debugging symbols. I will turn this off for now. Oh, and we run into a crash somewhere, but it's in the it's in the QVT library. That is not really something we are responsible for. What would they break here that it crashed? Interesting. It was time event when we triggered replot. We are refreshing it quite often. Maybe they have some sort of race condition that if it's not done with one refreshing and you tell it to refresh again, that then it drives them into a error state. So let's just go with I don't know, 10 refreshes per second. That should be slow enough. And we should get what that was in a test client. That was in a loop, or wasn't it? It was in a loop. So it should repeat the same test over and over and over again with 3-second delays in between. But I somehow suspect that there is something wrong because like 16 megabyte is not that much less than the bigger amount. So let's try a larger data block. And the goal for today should definitely be that we can get the thing to make the test with 1 megabyte in just a couple of seconds. So as long as it is not just a couple of seconds, then probably something is not yet working as it should. Test successful, okay. Let's add a progress indication. So let's go back to 1 megabyte. Now let's stay with this and add a counter that it tells us how long it took. So dwort start is equals get. No, that was get quotic. Get quote. What was get tick count? Get tick count. So this returns us the amount of milliseconds since the system was started, although the resolution of this is about 10 milliseconds. So if you like call it in a endless loop, you will see that it usually only increments every 10 milliseconds, so the resolution is not perfect. You can change this, but we don't care. Time passed. Let's click a tick on. Oops. Yes, and this should be here. Or we can call it always in the search of the shortest string that's still test successful in %d milliseconds. Comma elapsed failed in %d milliseconds. So one thing we can check whether the scaling behavior is okay is that we run it with 32k, then we run it with 64k, then with 128k, and so on, and see if it's just linearly scaling, which is the expected behavior, or if it's if there is some nonlinear scaling because there is something messed up within our implementation. Always takes so long. We also need to add the progress indication, otherwise the waiting is unbearable. I mean, to me it feels like it's still slower than what it was the smaller test case. I mean, is it even doing anything? Is it sending and receiving data? No, it's not. The buffer is just full and it's never getting emptied. That is not good. So we have a problem, and I guess receive is always empty now. Yeah. Okay, so there definitely is a bug somewhere. Okay, let's quickly add the progress indication. So we have a new line. Then here we add another new line, and here somewhere. Don't want to do it too often. That would also not be great for the performance. We could put it here. Each time we run out of buffer, we'll print out a progress message. Yes, printf %null, sorry, %d and comma, and we want \r so that we overwrite it each time, invoke it. And here we want to have let's go with the receive side. Actually, we could print really two progress reports for both values. So 100 times send len minus send total, and then the same thing for sv. That's for len, that's for total. And if you want to have actual % sign, you just do %%, so that should work. Let's see if that so just using \r should move the pointer to the cursor to the beginning of the row, and it does, but it's somehow our calculation is wrong. Why? Sure, we forgot to divide by total, no, sorry, by send length. But this time it finishes quickly, so it's either finishes right off the so it either finishes outright or it gets stuck with some error state that we don't see yet. So here, okay, it got what? It should not say success. Something is wrong with our display. So %d %, comma, comma, send length, send total, and receive length is how much we want to receive. Minus receive total, that looks correct. So this was okay. That we get multiple percentage at the end was caused because when we overwrite the line, then we have the characters left, and we had first just the 2 characters something. So let's just add some spaces to erase the rest of the line. Let's try it again, but this will not. I know why. Because we are not updating it often enough. Apparently at 6% was just the last time we decided to update it, and since then it runs and is able to send something each time. At least that's the hypothesis, but if it doesn't finish, then the hypothesis... No, it is stuck at this value. It's just stuck and not doing anything. But receive is also wrong. Retzv total. It could not receive more than it sent, unless we have the... Let's just really write down what we have. %d slash %d, and the other will be the same. So here we will want to have total, comma, send. I mean, the naming is not chosen ideally, because we would normally want total to be the total size and not the amount to send, but for now it's fine. Debugging such multi-threaded things is always not very fun. Okay, so it just gets stuck before the end. Then it should have showed 0% with our calculation. That's the mistake. It was showing the remaining percentage, not the percentage that was already done. So now this should work, but we still have the problem that it's getting stuck, and then we will need to find out where it is getting stuck. But that is doable. But why does it say test successful? Either it gets unstuck. Apparently it gets unstuck on the package reset. So it's dropping from time to time a package. But it's always dropping in at the same time, and then it gets unstuck. We could add here an indication that it's still doing something. Comma, let's see. How many do we need? 1, 2, 3. We need 3. Equals no, we need 4. Zack. Wait. Let me think. Okay, so we start. Let's start again. And we just leave it empty. We'll see how many we go. So we start with this character, then we want this character. We want something that like looks like it would be spinning. So we want this character, then we want that character, and then the thing becomes vertical again. Then so it becomes vertical, and then it needs to play the whole thing in reverse. Then it becomes this thing, then it becomes oops, comma, this thing, then it becomes this thing, and then the loop repeats. Okay. So cs table cpos modulo okay, let's see if that looks as expected. It is stuck, it is just stuck. When does it stuck? Is our receiving blocking? So we have here the no, our receive is not blocking. We lock the section, we receive. Should be fine. Also, it seems it maybe is broken. Oh yes, sure it is. I forgot to plus this. The indicator is broken. That's all. Yeah, it's rotating until it blocks. It was okay. So now it's waiting for receive. So because in this receive here, we can also, like, if we don't receive anything, we can also wait to receive something. So let's add here a second wait condition. Let's say if actually we also should have just a error handling here. Okay, so it will then just go from the one to the other. Then how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 symbols. Actually, we could wait. 8 is so that we can improve on the modular operation if we just, since we have an 8 symbols, we can go with, wait, what's 8, 7, we need 7, so it's 1, 1, 1. So we make this and 7. It will have the same effect, presumably. Let's try it out. Yeah, it's spinning quite fast, but it's somewhere stuck. Why is this stuck? How much we are missing? But we haven't sent everything. Just stuck here. Then we go out. Then we try to send something. We didn't send anything, so the send buffer is full. Then we print this as well. I mean, we can make a longer sleep here anyways, but this probably will not help the problem. Okay, Okay, with a longer sleep it works just fine. Also, I'm not sure why we get a percentage that's over 100. That should not be. Okay, so first of all, let's add one last line like this here. To ensure that we will not break before we have the full percentage. But this still should not end up with send more than with send more than what was there to be sent. Yes, the C doesn't exist. So the last line that we print will not show the spinning thingy. Total send. Let's go to hex. No, let's stay at hex. Yeah, it says it's sent more than it received, and it received less than it sent. But for some reason, this check said it's successful. So interesting. Is there any obvious mistake we made? So we always make plus send. That should be right. Send total, do we add send total somewhere where we shouldn't? No. That is not great. Let's quickly improve this slightly. Can move those out. Then, so we don't want to waste CPU cycles if both are null. So if wait, that's how. Oops, that was a typo. This one is supposed to be here. So if send is equals null and that's how is equals null, then we redo this. But I said it should not, unless it's an averaging bug. That could also be that it but we saw it with our own eyes that was not behaving as it should. Send total and send length, they should be equal, but they are not, and send total is indeed bigger. How can that work? Then it still claims that what we receive is correct. Receive profile plus receive total plus plus to receive. Okay, I mean we need to add some checks. So first of all, here do we have asset available? No. Okay. If to send, if send is larger than to send, that should never happen. Or yeah, let's start with this first case. Then debug break. And with receive we need the same test case. This should never happen. Although we didn't have the problem with receive, to be honest. The receive, if anything, received less than what it should. Okay. And then here another test case. Total send should always be less than total send. Wait, to send. Oh, damn it! I see the mistake already. To send should be send lang minus total send. So probably we will not need the test cases anyways. Let's quickly check whether it's working now. But then I'm really puzzled why our memcompare did not complain. Okay, this one was... we are missing the backslash r here. So this is working, but then the question remains why this failed. I mean, what we did was we sent more data than we had, and then when doing the receiving, that should have failed. That should have definitely failed. Okay, let's first run this again, and then we will introduce an error intentionally and see if our test case catches the error. Okay, so this works as it should. I mean, 4 seconds is rather slow, but why not? So here at offset 100, well, we don't know the offset. We can go at receive length divided by 2 is equals 1 to 3. So introduce an error, and then the thing should run the test and then complain that what it received was not what it was supposed to receive. But instead we run into a deadlock. Interesting. That is really strange. It should not behave this way, because if we divide this by 2, it will always give us a valid offset, so we definitely are not crashing here. We're just sending back bogus data, and the whole mechanism is just copying the data. It doesn't care for the payload. It should only complain at the very end. Okay, let's see where we are hanging. So here, this is not doing anything. Did we crash output? But then it should bring us to what crashed. So this should not. Maybe run into this break here. That's probably the only reasonable explanation what happens. Okay, now it worked. I forgot to check whether it said success or failure. I should at least complain that it's failed. Yeah, it says it's failed, so this is fine. But I'm still worried why it sometimes is hanging and sometimes is not. Okay, anyhow. So we need about 4 seconds for this particular amount of data, and now we will test a larger block. Let's go with 128. That is 4 times bigger. So we should take 16 seconds for this test to run. Yep, that seems okay. So let's now try the 1 megabyte. I mean, probably the 1 megabyte failed earlier before we had the sending conditions wrong. So 1 megabyte is 8 times larger, so it should be about 2 minutes, something like that. And 4, 5. Yeah, that will be boring. Let's just go with something bigger, but not so big. 256. That will be half a minute. And if this works fine, then it's good. Then the only question is why it is so slow, because it's rather very bad data rate. I assume the reason is that we here sleep for too long. We can then try reducing the sleep value to 10 if we then will have a faster transfer. So if we can speed up the half a minute which we should need now for the test. Yeah, that was half a minute. So let's go with a... Oh, and we have actually, we only also have this sleep here, which we absolutely don't need. So this, probably the first sleep was the reason why it was so slow. The second presumably was not even triggered that often. Okay, this is fine because we might not have anything. And it's broken. Okay, so let's debug that. Interesting. Where did it got stuck? It somehow is here just getting 0 all the time, I guess. Yeah. But why? So let's step through the function and see on which end. Because if a package was dropped, then the expectation is that it will be resent. So this should actually not be able to get fully stuck. Okay, this buffer size is 0, so the data was not sent. Data was not sent. Try send. Wait, so if the data wasn't sent, maybe it's a logic error in our mechanism. We had this mechanism that if we try to receive something, that we can ping the other side. But I think we have not implemented that. So I think the other so when we look on the other side, we have this try send. Was it try send or was it try to send? Try to send. I think this will never be invoked. That will be the problem. Yeah, we're never invoking our try to send. Let's see from where it should be invoked. So we are invoking it, of course, from our send function. That makes sense. We have it here, and we are invoking it from our function that processes acknowledgement packages. And for some reason, we processed an acknowledgement package. We called try to send, and it somehow didn't do nothing. Then so for in some way we have lost. So either we need some timer that will call this try to send automatically, or we have a problem with processing acknowledgement packages. But I don't really see where, since we don't have here any return. And if we write new data, okay. So what we can do to debug this, we could write some log output, or we tried just to fix it by sending this ping package. Let's maybe try that. So As you see here, we have the sequence is 0, which then is supposed to be just a ping package, and somewhere we need to have the function. Did we have a send ping? Yeah, send block null. This in process timer with advertised window was 0 and send buffer is 0. We send an empty block. Now this side should be fine. Let's try to get again into the error, and then we'll inspect this function if this one is not properly doing. I think we are really just missing one. Okay, this time it worked, but it should. If it now doesn't break, then it's annoying. Such intermediate bugs are particularly difficult to pin down. Because now it's working just fine. Before, it got stuck from time to time. Can we provoke that somehow? I mean, what we definitely need is this not process block, process app package, process, we have somewhere process timer. Yeah, this one. So if we have something in the send buffer, we will wait, send block. Oh, this should be working. For some reason, this function failed. Send timeout. Maybe you run into a timeout and then the connection just broke. But if you would run into a timeout, it should trace this. Then maybe we just need to set the trace level right, and see what it will be complaining about. QUMPC test. When do we set the trace level 2? Let's just always where do we create this thing? Test client here. So let's trace level 2, but do we want trace level 2? Let's check that. What was 2? 2 was medium, and medium was okay, let's just see what is high. Because high would be like the most, so this is sync package with too many okay, wait. And what is then low? Okay, so this is the priority. Okay, we're stuck with medium. This is fine. Let's see if we see something, and if we can get it to hang up again. If we cannot get it to hang up again, then of course we have a problem. Yeah. It's working. It is working just fine. We're not able to reproduce the bug. Strange thing was that it seemed to be crashing without a breakpoint set, so this might be a timing issue. But it's still working fine. And also now not having the sleep here, we improved our performance by a factor of 10. So this is already quite good. So we could here our test client go with the 1 megabyte one. Okay, now it's broken again. It got stuck, but we also have not get any error message. It just got stuck. And it got stuck. Let's see, we were probably sending. I mean, apparently sending. So we are here. We want to send something, but we just get 0 as a result. So if we step into this function and through the function, it probably is just there that we don't have enough room in the buffer. So the buffer is full, but it's also not trying to do any sending. Timer. Send buffer. Where are we? Call stack? Is this the right one? Socket process. Process timer. Yes. So we're entering here. Let's see. Send buffer has 8 entries, obviously. We would like to send something. Apparently this might not be correct. Probably all of the entries in the buffer have the useSendCount set to 0 because we had a race condition. So I think what's happening now is that sometimes we will issue the send command, and we have so many data on the way that it will not try to send anything, and at the same time this thing will then prevent us from sending anything in every subsequent call. So let's see. Buffer, there was an M. Buffer. Where's the send buffer? It's unfortunately not alphabetic, so send buffer. Send count is 0. Send count is 0. Send count is 0. Send count is 0. I mean, I'm pretty sure all of them will be 0. 0, yeah. Okay, so if we have 0, then we should run into this ping mechanism here. Let's see, advertisement window is 0. Okay, buffer size is not 0, so we should send an empty package. So we can get into this, and we will here. Yeah, this is fine. Now we should with a package type opcode data. We should receive it. First we will make send block. We send it, and then we receive it. Yeah, this is fine. Process block. Sequence number. Then we answer with a egg package with egg package with null. Okay, it's the other end of our ping, so we should receive it here. It's running asynchronously, but we are not receiving it. Interesting. That should not happen. So we are sending our egg packages as we should. We are breaking somewhere. Yeah, we are returning here. That's the problem. So here, zack, zack, zack. Send acknowledgement. Why are we always running into this? Okay, let's go back to so here process block. Yeah, we are processing a block which is empty, and this thing we should then answer with try send. Because this is an empty block. Something screwed up. So and we are try send. Process timer. So on process timer, we are sending here at the end an empty block. Let's write that down. What's happening? At least what's supposed to be happening. And we probably very quickly will find some. So this is our sender side. We run send empty block receiver. Okay, and on the receiver side, we receive this empty block. Op data. We process the block. We see that the sequence number is 0. We set off to send a acknowledgement package. And we cannot answer because here we don't have a window size. That's the problem. We need a window size. So what's happening is that for some reason the receiving buffer on our server side does not get cleared. Yeah, we broke. Shit. So for some reason this returns 0 and it broke. So let's add here a log line. Server how server receiver L /n. But this should not happen. So let's see why it might happen. We can wait. If buffer size is 0, it returns error. This is not correct. This should not return 0, it should just return 0. That will be the bug. We sometimes return an error while it was not an error, just we didn't have room in our buffer. Or rather, sorry, the other way around. Our buffer was empty. And then we break out of the other thing, and we'll never ever receive any further package, which then will cause the thing to break. So let's see if we now can transfer a megabyte without errors. Okay, we don't need the breakpoint anymore. And it is reasonably... It's still slow. That will also need some debugging. And we are deadlocked on the very last package. Okay, so I guess the server here is just looping through this loop, yes. Let's see what our client has. Send buffer size is empty and red's buffer is awesome. So this one does not have anything to do. So if we go to our test client here, the breakpoint there, and then check on this client, So the send buffer is also 0, and the receive buffer is also 0. There are no elements in here or there. Okay. Then if we go back to here, uh, 0, also 0. Weird. Where are we breaking? So this two are zeros total. Yeah, receive is missing some data. How did that happen? I mean, we can for now disable this. Oops, but it apparently is apparent that we still have one bug somewhere in our user mode TCP implementation, which will need to be found. In the end, we want our file transfer application to work reliably and not hang. Okay. Now it's hanging as well. So I guess here the send buffer will be full. Send buffer size, and buffer max. Okay, so the send buffer is full. So the server is just not receiving any data. But we didn't get an error. It just sorry, we got an error. Server receive error. Okay, this why would that be? Because we are not fully connected yet. Yeah, that will be the reason. Probably here we are in the connecting stage, not in the connected stage, and then we return an error. So let's just maybe make a continue out of this, so that if we have an error, we just ignore it. But this is not elegant, so we will need to improve on that later, definitely. Okay, we still have the problem that we don't receive all the data. Okay, at least the bug is reproducible. That is good. So let's add a counter. Int total relate. Just let's call it total. Yes. So total plus is equals. Oops. Plus is equals retsvlen. And since this is not a nice thing, we can make it differently. We can make a loop here. I think we have a getState function, which will just check for it to be actually connected. Okay, we don't have any of these functions, so let's make a is connecting function. So just while is connecting sleep tenant, we just need to define is connecting on our client. Connect dispose somewhere here. Is connecting const did we have it's defined here. Okay, well, one of those two. Okay, so we need to let's put it here. Yeah. State is equals what was it? Connecting one or connecting two? Connecting one loop, connecting two. Okay, so this bug should be handled properly, but we still, as I said, have the problem in large S where it does not count. So what we'll do is we now try to run into the other error, and once we are there, we will see if the server has processed the amount of data necessary, so that we know whether the error is on the sending or on the receiving side of our connection. Okay. Okay, now it's working fine. Interesting. So perhaps somehow causing this help the error to appear. So let's continue with that. Yeah. Okay, so it's somehow a race condition where calling receive breaks things if we call it before the connection is established. So now let's go here. So send. We know that send, because it says 100% is what it should be, and if we go here and go on our total, then total is also right. So the problem is in the data that are being sent back to our client. How is that happening? So we send sync. Trace and sync. Then we have trace server. It's for this is send sync arc, receive sync arc. It thinks it's sent as much as it should, but apparently it somehow... I see the problem. Here we are just sending it back, but we are not checking whether we actually managed to send everything. So it might be actually just a bug with our with this code and not with the socket itself. Yeah, because if this is not enough, this basically should be in a loop. For int to send back is equals, let's for length int send back is 0. This we just keep as send. So send back, so we have to send back minus send back plus send back, and if send greater 0, then send back plus equals send. Okay, so now we will invoke this a few times, and else yeah, if this is less than 0, then we have an error. If it's less than 0, then we have server send error. That's stay for now with the continue since we want to trigger the error condition. Send error, and here else just sleep. Yeah, sleep 10. Okay, let's run it. We don't have a break condition, it's stupid. While to send back is larger than send back. Actually, do we actually modify this? We don't modify it, we just have the receive length, so we can use this here instead. Yes. And it works. So now I said the question is why it is so slow and not faster than it could be. We can run here a test to start introducing package drop. Why is it not dropping? Ah, here now we dropped the package. Okay. So there are definitely things that could be improved. So for example, if we have a package drop, we could somehow try to improve and keep sending other data only when we see multiple package drop to really then make a break and resend the packages. That might be an improvement to the protocol, but it's working fine. So I think we found all the bugs that were in this thing, I hope. Let's here add a break, because we don't expect any error anymore after we had this is connecting check. Here we also break. Okay, any questions? I guess it wasn't very exciting today since we were just hunting down bugs in the code, but since we need a working user mode TCP implementation, this was useful. Also, it is good to learn how to debug such issues and where problems can arise. Yeah. Do we want to test anything else? We could try to find out why this is so slow. I don't think it's like too much CPU usage anywhere. What we could do is we could okay, there is first one thing to check, of course, when for the performance there is like a performance tracing tool in Visual Studio, so we can try that. I hope that's available in the community edition, but it looks like it's available. CPU usage, and when we run it and run our application for some time, then it will show us how much time different parts of the application are spending in which parts of our source code. So we will run it for the length of one test, and then we will stop it and see if we have a high CPU usage somewhere. Okay, stop collecting data. Can terminate. It will terminate the application once it's done with what it's doing. And we can select a region that interests us, for example here in the middle, because the CPU usage at the beginning, that was just the initialization of everything. Then we can go open details, and once it's loaded those, we can see in my opinion the call tree is the most insightful one. Come on. Okay, so this looks like just a drawing routine for our QVT library, so this is not relevant. And the rest we don't spend much time almost anywhere else. So here, as you see, our all socket processes are very CPU efficient. So the slowness of our communication protocol is not caused by any high CPU usage. So what you can learn from this is that it probably uses somewhere too many too long sleep directives. So we can check where we use sleep in our code. Use it here, for example. It is only on an error. No, so when receiving, when we don't have anything, then we sleep for 10 milliseconds. We can change it to 1, but I don't think this will help, because the default timer resolution is only 10 milliseconds, so the sleep probably will not be faster, will not be any faster. Yeah, it's just as slow as before, at least it feels as slow. What we can do is, of course, we can remove the sleep, and then we would be wasting a lot of CPU time, but it probably should be then a great speed up. Okay, so we needed 12 seconds, so if we remove the sleep completely, I hope that this will now be much faster. The other thing what we could change is, of course, we could change the buffer sizes. This also helps with transfer speed. Huh? It doesn't look like it's faster. It might be the sleeps that we have on our end with the inside the test code. It was just as slow. That is not cool. So let's remove this sleep and go back to our the server here. We can just really comment out all the sleep directives that we have. And here we also had a few. Oh, that was the problem. Sleep 100 is far too much. I think that we had sleep 100 there makes me bold enough to just remove the other, to re-enable the other sleeps and just reduce this sleep to 10. It also might be, by the way, the printing to the console which makes things slower, because the console is not very fast. So it already is somewhat faster. It was only 5 seconds. We can change this here to print it like not every time. So how do we do that the smartest way? Could make it like if if this thing, to always have a plus plus. Yeah, let's look like this. If e plus plus shifted by how many bytes? Let's go with 7. If this, no, the other way around. The other way around. If this and null x7f is equals null, yeah. So if this is null, then we print, but then this needs to be changed. We want to shift it by 7 bytes, bits, by 7 bits. Didn't I have an improvement for that? I had an improvement that apparently got copied and pasted away. And null x null 7. C plus plus. Let's go with plus plus C so that we always have the right thing. If this is equal to 0, okay. Let's see if this improved in our 5 seconds or not. Probably not, probably just the sleep is what is causing the slowdown. Okay, we have a bug in our code. Okay, so just the sleep is responsible for the slowdown. It is not this, and the code I wrote apparently doesn't work. So the idea was that we print every 100 iterations, which apparently was not right. Let's see. But it increments, then it checks F7, and it is every 100. So every 100 was just too much. So let's go with every 16th. Also, it was not really every 100. It was like every 128th. And shift by 4. It should count through as well. Let's see if the animation now works with this repetition rate. Yeah. But it didn't become reasonably faster. Also, the animation doesn't look right, so probably maybe I need to swap those. Yeah, I think I need to swap those two for it to look correct. Let's see if it looks better this way. Okay, but we have still the 5 seconds, so let's comment the sleep out and see how fast can we be. So now we are benchmarking how fast our protocol can work under ideal conditions. It's only slowed down by the print to the console, but it still was just 5. Okay, so let's remove the console printout, and if we here see a slowdown, it will have a slowdown. Let's remove the sleeps we have here, because they will be slowing things down. And one other sleep we might want to remove is this one, but we will see if we need to remove that or not. It was just still 4 seconds. We are sending only a megabyte of data. 4 seconds is a long time for only 1 megabyte. Yeah, better. So this sleep here is a performance killer, but we somehow need it, because without it this loop would just consume in one whole CPU core, which we don't want. So since we are running out of time during the next lecture, if you find these things interesting, we will look into improving on this so that the thing becomes faster. Yeah. So are there any questions? Okay, no questions. So I'll upload the fixed version to the Moodle. As seems the only thing we needed to fix in the actual socket code was the one mistake that was reported, that we already had a change in the code when we started today. The other issues were only related to the test code. But it looks as it works quite reliably. So if we enable package drop with the test function, it also is successfully recovering and retransmitting packages. So that might be a good protocol. Okay, so see you next week. Bye bye.